Hello and welcome. Today we're going to be doing another segment of our general aircraft familiarization for aircraft rescue firefighters. We're going to be adding on to what we've learned already in our previous video, which was on the Cessna 172, which we covered the basics of flight, more simple aircraft, crew, pilot egress, some hazards involved with prop-driven aircraft. So we've got that down. Now we're going to make it a little bit more complicated, and we're going to be talking about an introduction to jet aircraft here now. So specifically, we're going to be going over the Cessna Citation CJ4, a business type jet that's very common to a lot of airports all over the world, and that's going to give us the basics of just a more complex setup of what we got going on here. So let's go ahead and get started. So the basic, I just want to give you guys just kind of some of the parameters of CJ4. So we have its cruise speed is now we're up to 450 knots, which is its max cruise speed. It's not always going at that, but you can see this 450 up from in the 100s that we were looking at with the 172. So we're going about almost 5 times faster, and we're using a totally different type of airframe. Another thing that's a lot different is the altitude. This one cruises at an altitude about a little bit above 30,000 feet to 35,000 feet, and when we're thinking of that, then that means that the air up there is much thinner. And the thinner air, of course, that means we have to go faster, and there's the higher speeds. That works out for our passengers because that actually means that they can make it to their destination a whole heck of a lot faster, right? So a few more things. Let's talk about like how many people can actually fit inside this thing. So there we go. We got our 2 crew up here in the front. There's a lot of different setups that you can actually get inside of the Citation 4. There's a lot of customization that they can actually get. But what we have here is a 6-seater plus 1 jump seat here. And we might actually have someone tagging along, like someone actually tending to the passengers too. So, and they're also facing in different locations, right? Nice, plush, very comfortable seating here. 2 are facing to the rear. We have a couple facing forward, right? But it still could be a pretty compact compartment is what we're looking at here. All the way in the back, there we go. We got the lavatory here. And there's a sliding door. You can almost see the sliding door there. And that's how people get in and out of the lavatory, right? So when we go through this and we're looking for passengers, right, we don't want to forget those lavatories. Up here towards the front, there we go. We got our 2 pilots, pilot, co-pilot, and the flight deck. So we also have 2 people there. Very narrow entry right here to that. And of course, unlike the commercial aircraft, we're not going to have, we may not have a ability to open up any of these windows, kind of like, we're looking on 737, so they have a kick-out window there, or an operable window that we might actually be able to do pilot egress out of a window. That's not really going to be an option here. We only have this, we call it L1. It's on the left, and it's the first door, so there's L1, right? And it's you see the stairs there at the bottom that actually drop down, label pull to open, right? And it just kind of swings out, and then to the side we'll show you for here in just a moment here. And then back here in the back, well, I can actually show you from the exterior of the aircraft. I'm going to show you where the other exit is. So here we go. So this is a pull out, right? And then it swings over to the side on this one. They don't all swing over to the side in commercial aircraft. Some will actually drop straight down because the stairs are actually built into the door. On this one, it'll swing out to the side, and then the stairs will actually drop down like we saw before. And then we're going to go over here, and we're going to see there's another exit right here over the wing. Okay, so the hazard associated with that exit, we can see there's the intake of the right engine. So of course, you probably wouldn't want to go piling out of that if that engine was running, but of course, when we're using that, it's most likely in the scenario that there's either wreckage or everything is shut off and done. So it's an emergency, last chance ditching of the aircraft when we're going out of that egress. But most likely, people always go to the door that they remember coming into, and that's going to be L1 right there. So that's where we're going to try first if we have to make entry to this aircraft too. So, like I said before, we're at higher altitudes, right? Well, that means pressurized cabins. So we're going to have a far more reinforced door than what we saw on previous aircraft. When we're looking at the smaller TA aircraft, there are a couple zips and a couple pull a couple pins and the door comes off. Well, not so much with this one. We're going to have very heavily reinforced in areas around the doors, and I want to show you guys a diagram so we can kind of get a feeling for what that's actually going to look like. So I'm pulling up this diagram here. This is a Cessna Citation. This is just an overview of what we see there. You can see the door swing out, and you can see how the stairs drop down. Now you can also see that there are some there are large structural members that go down the entire length of the aircraft and wrap it almost like an exoskeleton, right? So, or sorry, the skeleton of the aircraft. And those are, we're going to have to, if we have to go through those, there could be a lot of cutting and a lot of different hazards associated with it there. Now, another thing I want to do is we're going to start right at the tip, and we're going to talk about a few more things here. We're going to go right into the tip of the aircraft here. So there, this right here is going to have a lot of avionics inside of it. This is where the radar is, and that's going to be how they can actually accumulate some weather and some other avionics too in there as well. What's important to us to know is that from this section here forward, we're going to have a whole heck of a lot of stuff in our way once we get through the skin, and it's going to be stuff that could potentially be hazardous if we're cutting into it. A lot of wires, a lot of entanglement parts. So here, there's you can kind of barely see it here, right here. Oh, sorry, I actually want to click this off so you guys can actually see what I'm saying. What I was talking about before is right up here in the front. That's where the radar stuff is, right here in the front nose. And then right here is a compartment. It's an additional luggage compartment. So it's just open there. Underneath here, we're going to start running into hydraulic lines, and we're going to start running into other parts because we start seeing retractable landing gear here in the nose. Okay, so it has a, inside here, there's a chamber that it all fits up inside of it. It's hydraulic powered. And you can see here's like the main leg of it here that just kind of like a shock absorber in your car. That's riding up and down inside of the channel. So when that channel itself has gaskets on it, and if it lets go, just like a shock absorber, if the oil sprays out, and then this can actually collapse, and then of course your nose can drop by 6 to 12 inches, depending on how much travel there is in this riding arm here. So we're also landing at higher speeds, and our takeoffs are higher speeds. So the likelihood of us seeing more gear-related things with these aircraft is more likely, because we can have harder landings, we can have burst wheels, we can have collapsed struts. These things are all hazards that we have to start looking out for. So we're just we're making a whole heck of a lot more speed when we're landing or taking off. Windows here, important to realize, far more air pressure when we're pushing at higher speeds of 451 knots. So we're going to have very thick windows, right? There's de-icing bars inside here that should prevent icing on there's heating elements that prevent icing on the windows, right? So, and we're going to see a lot of de-icing stuff on these aircraft too as we're going around it. So these windows, very thick, very difficult to get through. You're not going to really be cutting through them with a saw. It's just going to shoot a lot of plastic ribbons because it's not straight glass. It's kind of a plexiglass composite and very a difficult cut. So we're going to probably go through metal if we absolutely have to. But then you have to remember, inside of this main flight deck, all the avionics and controls that are all behind this main dash area here, we're going to be running into a lot of wires and a whole lot of stuff that's going to be getting in our way. So we're going to be looking more at the top and maybe taking the window inside itself. We're trying our best to get into a rear egress, through that L1 door, if we can actually get inside that one. So kind of moving on down, like I said, highly reinforced doors here. These windows here, they are reinforced, but they're not as bad. So you can actually knock these windows in, sledgehammer, something along those lines, is if we have to get these windows knocked in, we can actually do that. We can also take sandpaper and we can start rubbing the paint off the side of this, and we can actually see the double rivet lines down here, which will actually be the floor of the aircraft. Maybe more up here, where we don't have this additional kind of bevel here on the side, or the structural reinforcement of the wing. Further up here, we'll actually be able to see our, if we can sand it down, we can see the double rivet floor level. And then we can see where the floor of this area is, and we can actually cut 2 windows out, right? And we're going to follow just on the inside, and the rivets are always a good indication of where we're going to be able to do those cuts. So what I would do is I'd knock 2 windows out, I'd do cut down on the side, right? And then I'd cut the bottom, and then I would cut the top. If you cut the bottom last, then that whole panel is going to be pinching your blade, and you're going to have a whole heck of a lot of trouble doing that. So if you actually have to go inside this side, that's where I do my cuts, because there's not as much stuff here above that floor line. A lot of the stuff is traveling down here towards the bottom. Okay. So now looking at our wings, it's important for us to realize that our fuel type changed, right? We're working with jet now, so it's jet fuel, similar to it's like kerosene, almost like a diesel fuel. Very difficult to light with a match, right? But it's going to be a higher volume. The problem with jet fuel is it may not light easily with direct flame, but once you get some heat behind it, it can ignite very easily, and it can be very difficult to maintain or to extinguish once it gets really rolling and it has a lot of thermal energy behind it. So we're looking at about 100. So max loaded here, after looking it up, we're looking at 1,122 pounds of fuel in each wing. Not each wing total, right? So it's a total of 1,122. That translates to 130 gallons of jet fuel split between the two wings. So we know that that means that if we have a large amount of fuel in the wings and ruptures and breaks in the wings, that we're going to actually run into some problems there too. Refueling occurs, that we can actually do over-wing fueling, right? So they can actually refuel on both sides, and they can fuel through these over-wing ports here on this side. And also, if we swing around to this other side, there's a single point connection, the one that you guys have probably all seen, where it clicks in. And the controls for the single point connection are going to be inside of this door here behind the right wing. So that's where your single point connection occurs. And there's a little grounding point there, or they can ground out on the landing gear. I'm pretty sure there's another one here towards the wing. I can't tell you absolutely sure. But they do need to be grounded out while refueling is taking place. So that's another safety consideration there too. Looking more at the wings, I have these spoilers. So here we go. The spoilers is the ones that are sticking up here at the top. And those are used to slow the aircraft down. And then I got the flaps fully extended here too as well. And of course that helps, as we said in our video earlier, that when we have aircraft that are designed to travel at higher speeds, you can create a cushion of air underneath the aircraft, and we can actually land at slower speeds. So flaps become central in aircraft like this. Otherwise, we're going to be landing very quickly, and that can actually cause some hazards too as well. Now, you can look over here. You see this leading edge of the wing, and as we're going down now, we are going to talk more about icing in a different video. I want to do a video entirely about the icing hazard to aircraft, but that is a heated element that goes down the entire edge of the wing, and it is designed to mitigate the accumulation of ice, right? So you can see we've got one on the engine, and then on the tail too, sometimes you'll see a silver one on the tail or the leading edge of the tail to prevent icing accumulation there as well. So that's where you're going to likely see some hazardous icing accumulation to the aircraft. It messes up the aircraft's ability to maintain lift, and icing can be very bad. We'll go over that later in a different video. I don't want to get too caught up in that right now. So just kind of moving down, we have two main engines, the power plants here, right? So they're kind of sitting off to each side. Now hazards, of course, are the intake. If those are running, they can suck things in. They can cause trouble there. Anything flying in there can actually cause a whole lot of trouble. But the main one I want to bring you guys out is when we have an exhaust, we have running engines. That's at helmet level, right? So if that's at helmet level and you're walking around an aircraft with that running, and you poke your head around the edge of this and you just come around here, well, it can knock you for a loop, with the exhaust gases off of that. It's not a whole lot of fun, but it can cause severe neck injuries, head injuries, all kinds of different stuff like that. Plus there's heat, just mind those. Get yourself down, even if we got to, kind of crouch and stay nice and low below that jet blast, right? So going around here, we got a rudder. We have the trim tab on the rudder. We're talking about trim tabs in the other one. Same as trim tabs, elevators, all that kind of stuff. Okay, so now we're coming around the opposite side, and we have a pretty good understanding of the external of this aircraft, right? So now I want to talk about the differences between jet engines and when we're, and some hazards associated with that. We're going to kind of understand those better, that are different than the piston-driven engines that we saw before in the previous aircraft, in the 172. I'm going to show you a diagram here just to kind of get an idea of what we're actually doing. So you remember, like I said, this fuel difficult to light with a match at our current pressure. So a lot of it has to do with pressure. So we have a different diagram I'm going to bring up here. Here's a jet engine diagram, and you can see that this one is just a little bit different, well, quite a bit different actually, than what you guys would see with the piston one, but it's actually a simpler engine if we think about it. So what we have is we have a giant inlet on the side, so that brings in a whole heck of a lot of air, right? And then there's fans. There's the big fan that you see, and then the fans are designed to compress. So they're compressing the air down through the different array of compression fans and getting the air in a really tight channel at a much higher pressure. That's when a fuel injector comes in and takes that highly pressurized air, mixes it with fuel inside of the combustion chamber, right? And then puts a light to it, right? Where the light keeps it going. Well, that highly expanded hot exploding gas then pushes out the back of the turbine fans, and that turns the whole thing along a central shaft. And then we have the exit nozzle, and then we see the exhaust actually going out the other end. So we have the intake, compression, combustion, and as it's blowing up, it's the explosion from the jet fuel mixed with pressurized air is then going to be open on one side, closed on the other, and then that's going to push against the engine and then drive the entire craft forward. So that's where your push comes from, kind of like bullet, right? Because it's only closed on one end. And then also those exhaust gases are turning a fan in the back, which are turning the compressor fans in the front, which are sucking in more air and compressing it down. Now, the reason why this is really important for us to understand is that it's a very simple concept, but the reason why that is important is because, like a diesel engine, that means that we don't have to continuously be giving electrical energy to this engine in order for it to keep running. These engines can continue running on their own until they're stopped. And that's important for us to understand, is because when we have total electrical power out, then we're going to have to cut its fuel in order to get it to stop. Or we can drown it. And I'm going to talk, and the reason why I mentioned that too as well is if we have a fire inside of our engine, we have several options available for us. Here in the front bell housing, we can direct the stream in there, open her up just a little bit, and just open up, to get a good full intake of water in there. And it's going to travel through the entire stem of that engine, and it's going to drown it out, right? So if we have to take an engine down one way, that's a safe way to do it. And I would just use water on that. But when we're dealing with, fires, and if extensive fires are occurring in there, then we might have to consider the foam option. But if it's something where I just want to take an engine down, then I would probably just use water to begin with. And in the exit, we can come in from the other direction and send it up the other way. But remember, we're going to have to be going through all those fans on the exhaust end, and they're probably not going to make it into the combustion chamber, but it's not going to make it so much into the compression chamber. So we might have to do a mixture of both, or we're going to have to try different methods if we're going to use that method in order to get the engine down. Now, there's a lot of quarter turn nuts on this guy of the Phillips nature, I believe. So the Phillips push them in quarter turn, and we can drop the panels of this engine down if we need to get in there closer to stuff, because there is a plural or an empty space around the engine between the outer cowlings here and the engine itself, because the engine can sit kind of lean in there, and there's a lot of things in there like little fuel lines and stuff like that where we could, if we continue to have fire, well, it could be resting inside of that empty space around the engine, and we want to get it before it starts, traveling through the mounts and then getting to the interior of the aircraft if we're dealing with engine fires there. So that's important to do. Another thing to notice is that, well, we have these fans, and even on the compression end, and all these fans, when they're spinning at incredibly high RPM, if debris gets in there, or if they get off sync, or they start wobbling, well, they can throw fan blades, and those fan blades, each one of them, they could be weighing like 25 pounds, and it's solid machined steel, and it's flying at incredibly high speeds, and it's going to throw out into a radial pattern, right? So typically, that's why we don't have passengers, right back there by the engines, right? Well, that, and there's a whole lot of other support equipment for the engines, going through there. Everything behind this is just a real big mess as far as like wires, fuel lines, and things like that. So cut-ins and things like that from the rear are going to be very difficult. But we want to remember that. So we don't want to try to stop an engine by throwing anything in there. So if we throw something in there, which is kind of like an old, we have Some guys will say that almost as a joke in the ARFF world, but I'm telling you, absolutely do not do it. We don't throw anything in the engine to stop it. Okay, it's going to it'll make this engine wobble. It'll at high RPMs, it's going to throw a blade. That blade can go through the side of the engine cowling and go flying over here and hit somebody, or it can fly into the aircraft and cause a whole bunch of damage that we don't want. So water, drowning it from the exterior, good way to go. Another way is if you can get to the fuel lines from the interior of the aircraft, you can have the pilot shut off the pumps. You know, it's going to spin out the rest of his fuel, and then that's going to take the rest of it down there too. We could do a more advanced video later where we start hunting down like how to actually to handle fuel lines from the exterior of the aircraft. And another important thing, so that covers engines pretty good. Hopefully everyone has a good understanding of that. So we're also going to talk, last thing here on the exterior of the aircraft is right here is the battery compartment. Okay, so you can actually see that bat access. This battery compartment, I believe they still have a quarter turn twist or a half turn twist. Pretty obvious disconnect for the batteries. If you want to shut off all electrical to the aircraft, that is the best exterior way to go. Going to the battery access, do it that way. You can see here this external power receptacle, 28 volts DC. Direct current, that's the ground power GPU plug-in. So that long cable out of that GPU plugs in right inside there, right? And there's an electrical hazard to that too, definitely enough to hurt somebody if they got electrocuted by that, hurt or kill. So that's the electrical hazards we need to be aware of too. And because it is not uncommon to have GPU fires where the external unit itself catches on fire. We got to get it away from the aircraft, right? So we might be dealing with that too. So we have to be careful as we're moving into those things too. So we covered jet engines, the differences of the engine types. We talk about fuel. So we got a heck of a lot more fuel that can actually be, on the ground or involved inside of our emergency. Okay, so the last thing that I want to do while we're going through this aircraft is we're going to talk about the startups and shutdowns of this aircraft. So I'm going to go ahead and we're going to go ahead and pop inside real quick into the flight deck here. All right, you see I have a blacked out dash. Nothing's turned on at all. So let's go ahead and get these engines fired up. So I'm going to start over here on the left. So I'm going to turn, this is our battery, and then we have avionics. Okay, so a lot of these, it can be pretty complicated. When we first see this, but we have to remember there's a whole lot of this that we aren't going to use. We're not going to use anything that has to do with radios. We aren't really that concerned with all this stuff that has to do with, the flight displays. We don't care about the autopilot stuff that's up here or the flight director and all that kind of stuff. We can actually see a couple warning lights that might tell us something, right? Another nav information here, but we're really going to be concerned with everything in this part and then down this part right here to do with the engines, right? So there is a yoke here. So you can see it. I'm just taking it away so that way we don't have to worry about that. So we're going to start it up, and then we're basically going to do the process in reverse to shut it down. So we're going to have battery on. There we go. And then we're going to right here turn our avionics on. So that's going to turn on our flight displays. Okay. And then we're going to come down here and we're going to turn on our fuel pumps. So we're going to fuel pump. Then we're going to go fuel pump. Right. Now our ignitions are already on, but they could be off, so that the ignitions would kind of be going on too. And then we can see here, engine's not doing a whole lot. So then over here, so we have our throttles, okay? And then here, this is our speed brakes. Remember the spoilers on the side? So I'm going to put those to 0, but when they pull them back, that's full speed brake. But I'm going to go ahead and put these up. That's not really important for what we're doing with the engines. So I'm going to go ahead and take the engines to run, and then to run. And then we're going to go ahead and start left. All right. So then, looking over here, you can see this in percentage, it's a measurement of the RPMs. So we want to get this guy up to about 60. Now that's not really too important. But the one thing that we can look over here, and one way of knowing, hey, are my engines running? Well, if we have an in percentage here, then our engines are spinning. So that's is somewhat important for us to know. But we're just talking about the basics of flight. And I'm telling you guys stuff that you probably beyond what we need to know just for the shutdowns of this thing. But I do want to tell you from the pilot's perspective some of the stuff that he's dealing with. So we're at 32. We're going to wait till it gets up to the 50s. And then we're going to go ahead and start up the right. engine here. So 40, and we can hear them winding up, and that starter is going to turn off on its own. 50. Okay, let's go ahead and fire up right. There we go. And our throttles are still at idle. Okay. And now we can see right, 7, 8, and it's throttling up to as well. So I just overrode some of the warnings. We, of course, don't have to worry about that. $23, and then just let that guy really go. Okay, so starter engine off. See the left starter is already off. This guy's still going. Just takes a moment. We can kind of look around while we're waiting for that to start up. Talk about a few things. All this up here, life support stuff, right? It's your air, we adjust your crew air. But with these aircraft, not a whole lot of overhead panel. We'll start talking about overhead panels when we start getting into commercial aircraft. This little thing's for your landing gear. It tells you where your landing gear's at. Right, it's landing gear warning. Over here on his pilot's left-hand side, kind of important. These are fuses, you know, so that's all in amperage, if I'm not mistaken. So these are all different fuse tests for amperage of different parts of the aircraft's systems. And there is a battery disconnect switch right here, but of course, you know, if we go for that exterior, that's probably the way to go. But the pilot has a button here too for doing that. Okay. So another thing that's important while we're waiting for this to go is right here. Is we have emergency brakes here, right, and right here. That's where our parking brake is at. That could be important depending on what's going on. All right. So parking brake locks the wheels, right? So that could be important, especially if we respond to an emergency, maybe something to do with something happened to an aircraft while a line technician was towing it, or maybe he was towing it with the parking brake on and caused some kind of harm there. So just being aware of like how all this different stuff too. The other thing here is this is our dump for our internal cabin pressure. That's where this switch is here. So this is all your pressurization controls, which are right here in the middle. And there we go. Now we're all spooled up. We're at 16 on both sides. So let's just say that we come in here, we have a double incapacitated pilot. This thing's just sitting out in the dirt, you know, but it's still fired up and it's still going. We make entry and we have to shut down this aircraft in order to safe it so that way we can keep working on the crew. Maybe one guy's in the back working on the passengers, trying to get them all, you know, ready to be packaged up and taken out of the aircraft, while the other guy comes up here and performs a shutdown. So how do I want to do a shutdown on a CJ4? So what I'm going to do is, you know, you guys know the terms, throttles, bottles, batteries. It's a little bit more complicated than that, but the first thing I'm going to do is I'm going to pull these throttles all the way back towards me. So throttles all the way back. And then I'm going to hit from run to stop. So then we're going to stop these. And as soon as I do that, look at our in percentage. It just starts dropping. Okay, so the RPMs, it's not spinning anymore. Excellent. So that's dropping down over there. But now I want to save some of the other systems too. I want to kill the fuel pumps. Off, off. Remember to kill the ignitions, great. But the most important one is boom, boom. Fuel. Okay, so you want to cut off fuel to our engines. Over here, main one's the battery. Kill that one. That's going to kill the avionics too. So you don't have to switch this avionics one, but the battery's the nice red switch. Look at that. And now I have a fire safe, not necessarily fire safe, we can still have a fire somewhere, right? But I've done my best to safe the cockpit in order to get everything, you know, shut down in shutdown mode. What I would do then, the secondary on top of this while we're working on it, if this was a structure, if it has some structural damage to it or something like that, after I do this, I'm going to go back and I'm going to disconnect that battery. All right. Now here's an important thing. We're not going to disconnect the battery first because, like I said before, those engines need to be shut off. So as long as we have electrical, up here, if our master's on, you know, and avionics is going, you know, then my buttons and everything are actually going to work. So it's actually going to get the signal to shut off the fuel pumps, and is, you know, then we still have control. So I want to disconnect, if I can, wait till the last thing. All this is all shut down. Then I'm going to go out on the back, open up the side, and then I'll disconnect that battery. right? So I do need to do it this way. I do need to have that in order to shut this stuff down. Otherwise, this will be black and those engines back there, if it's still getting fuel, and it can still get fuel out of the lines, it'll still be spinning. So that's why we want to make sure that we do things in the proper procedure. Okay, so go ahead and rewatch that bit. I won't take you guys through the whole thing multiple times. Go ahead and rewind that shutdown procedure. Look it up on your own. And remember, these videos are to be used in combination with actually walking around real aircraft at your airport. So simulators aren't everything. They're just one opportunity. Like today, when we have we have cold weather. I can't take the trucks out right now because we got ice. So I'd like to, well, let's fire up a simulator and just study how some of these switches go. So please don't use this as sole training. This video is used, and also this is all just based on my best knowledge and what I've been able to find with different documentation around. So these things are all subject to change, right? Definitely review your local policies and your SOPs and SOGs. Make sure you do the due diligence on that. But this is from my best knowledge in my career. This is how I'm teaching, to do things. If you have any suggestions of things that can be done differently, absolutely hit me up. And I look forward to hearing from you there. All right, guys, fly safe and keep learning. Until next time.